Okay, so now in this example, we're going to use a previous example to demonstrate how we would calculate the absolute error and the relative error for using the midpoint rule. Okay, so in a previous example, we used the midpoint rule to estimate this for 4 subintervals. Okay, and so in that we found that m sub 4 was equal to 21 over 64. Okay. But then we also found that this interval or integral is equal to 1/3. Okay. And then we also found, so if we use the absolute value, we did this before, but let's now formally do it. If we find the absolute error, well, we find the absolute value of the difference between the actual value and the estimated value, right? Okay, so in this case, it's going to be 1/3 minus 21 over 64. Now, we found that when we did this, we got 1 over 192. And so the 1 over 192, or which was approximately equal to what? It was 0.0052. Okay, so that's the absolute error. Now, what about the relative error? Well, the relative error would be the absolute value of the ratio of the absolute error divided by the actual value. So it'd be 1 over 192 divided by 1/3, which would equal what? The absolute value of 192, 1 over 192 times 3. Okay? Which gives us the absolute value of what? One over 61? Is that right? Nope. 64. Oops. So the absolute value of 1 over 64 would be the relative error, or 0.015625. So approximately equal to 0.15, sorry. 0.015625, or if we write this as a percentage, which is approximately equal to 1.56% error. Okay, so this would be the relative error. This is going to be the absolute error. This is the actual difference between the two measurements, right? This is the actual difference. This is the difference as a percentage of how off it is from the actual amount. So the estimated amount is off by 1.56%. So it's higher. So we're overestimated by about 1.56%. Okay? Of what? Of the actual value. Okay? So that's a way to look at it. Okay, that's it. See you next time.